All right, good afternoon, everyone, and welcome to the Digital Learning Network. My name is Michael, and I'm going to be your host today as we learn about what an analog mission is and what the engineers and scientists are doing right here at the Johnson Space Center. Now, we're coming to you live from the Johnson Space Center in Houston, Texas. And a quick question for you guys. Does anybody know what we're famous for right here at the Johnson Space Center? What do we do here at NASA? Who knows? If you know, raise your hand, and your teacher will call on you.
Do you help design rockets?
Design rockets. Well, we do design many different things. Yeah, rockets is one of them. Robots as well. Oh, another one.
Test what happens in zero gravity.
And might have to have a teacher reiterate that close to the microphone.
Test what happens in zero gravity.
Oh, what happens when there's no gravity? Actually, we do lots of different simulations where we try to simulate microgravity, which is a very unique environment that the astronauts experience when they're actually up in space. Good job. Now, we're also home to the astronauts. We train them right here at the Johnson Space Center, and we have mission control, where we control the operations of the people that are actually up in space, like up on the space station. Now, I've got a shot right here of the Johnson Space Center, and we're actually coming to you live from this building right here. It's a very special building called the Space Vehicle Mock-Up Facility. And here we have real life-size trainers of the International Space Station, of futuristic vehicles like the Orion spacecraft, and we've got some new testing going on the far end of the building, and that's what we're going to talk about today. Analog missions, where we're simulating what it's going to be like to actually go out and journey out into space farther away than low Earth orbit, like going to an asteroid or maybe even going on to Mars. So we've got lots of amazing facilities right here at the Johnson Space Center. Now, you probably saw I've got two guests right here, and I want to introduce them right now. We've got Barbara Janoko. She is the mission manager for the analog missions. And we've got a crew member, David Cohen, who is actually a spacewalk officer, who is also going to a crew member here for the analog missions, and he's actually lived in this very interesting vehicle right behind us, and he'll talk to you about that in just a little bit. So we're here at the Johnson Space Center. We've got an amazing program for you. Now, right off, can you tell us what an analog mission is and what you guys are doing here for this test?
Yeah, well, analog missions are tests that we conduct in environments that are like space. So what we're doing here is simulating an asteroid type mission and using some of the facilities available here on site.
All right, excellent. And you being a crew member, you guys actually experience it firsthand. What is it like to actually go in and do all these amazing different things here on site?
It's actually pretty great. You know, we have a very good simulation set up. So when you're inside this capsule that's behind us, I've lived in there for 3 days, and we project a simulation out in front. So when I look out the windows, it looks like I'm actually at an asteroid. And we practice flying around the asteroid and collecting samples off of it. So it feels like you're really there and doing it for real.
All right, well, I want the kids to get a little idea of what it's like to actually do these analog missions. So I've got a little video here that I want to show, and it talks about all of the different types of things that you're doing right here. So if you could talk to this real quick, we can show a little video about all the activities that are going on.
Okay, well, what you're seeing there is the multi-mission space exploration vehicle, and we did some testing with this back in December and January, and here in the same facility that we're at now. There you can see the simulation playing on a screen that was positioned in front of the cabin, and the crew sat inside the cabin in those two seats and flew the simulation. There you can see the simulation. We're looking at an asteroid named Itakawa and using real data that JAXA, the Japanese Space Agency, collected. And so the crew back in December and January also lived in the cabin for 3 days and 2 nights, just like what we're doing here. They used a Mark III mock-up suit, which is a suit very similar to a real pressurizable suit that we're using here on site, and they performed suit port operations every time they went EVA. For EVA, they went into a virtual reality lab, and there they were in the suits and flying around the asteroid and performing operations on the asteroid. We also use a facility called Argos, which is a gravity offload system, and we simulate the gravity that would be on an asteroid and had the crew use EVA tools in different areas set up under the system to see how they would do science on an asteroid. We also had the crew get in what we called an air chair, which floated on a floor much like a air hockey table, and we also flew the cabin on the air-bearing floor as well, and perform docking operations like what you're seeing there, because ideally you could dock the MMSEV to another MMSEV or to a habitat.
That's amazing. Looks a lot of fun. All right, so those are just some of the activities that are going on during these analog missions, and it's amazing how they can actually pull everything together and actually make it happen. But it's not just a few people that actually do it, right?
Right.
It's a whole team working together.
It is, and the team is from across all different NASA centers.
Okay.
Primarily, we have folks here in Houston, in Florida at the Kennedy Space Center, and in California at the Ames Research Center.
Okay. And you guys work real closely together, maybe have morning meetings and find out what you're going to do for the whole day, and then go into action?
Yeah, every morning we have a group meeting, and we meet again at the end of the day to replan for the next day.
All right, excellent. Now, during this program, I will stop and offer opportunities for you guys to ask questions. Do we have any initial questions about the actual analog mission so far? And it's okay if we don't, but start thinking about some. If you have any questions about some of the material that we're talking about today, or something really interests you, please feel free to raise your hand. Nope, no questions right now? And real quick, give me a shout out if you can hear me. I'm not sure that the video is being transmitted. I want to make sure that we've still got a good connection. Yeah, it looked like they had a little difficulty. Maybe it froze up. So we're going to pause right here and let them call back and connect. And
Sorry.
that's okay. Do you have a lot of network traffic at the moment?
Actually, it was me. I hit the wrong button. No, we're back. Sorry.
Okay. Well, I just want to take a little break. I wanted to see if you guys have any questions about what we talked about so far. Anybody have any questions?
Go ahead.
Oh, there we go.
Are you constantly training astronauts or not constantly?
Are we constantly training astronauts?
Yeah, we do constantly train astronauts. Every single day we train astronauts to do everything we do on space station down here at the Johnson Space Center. So we train them on how to live in the space station, how to go out and do spacewalks, how to work the robotic arm, how to fly the vehicles that go to space station. So yeah, pretty much every day.
Isn't that 1/3 of your job, maybe?
It is, yeah. That's what I do a lot of the time when I'm not doing something like this RATS test.
Or working on console to make sure they're doing a good spacewalk up in space, right?
That's right, yeah, exactly.
Okay. Yeah, so he's not doing that. He's training them right here at the Johnson Space Center. Good question.
Thank you.
Any more?
One more. Go ahead.
How many Apollos were there? Like, you know how Apollo 13 and stuff? How many were there?
Oh, how many different Apollo missions were there?
Yeah.
Oh, well, there are
Yeah.
actually 6 missions that landed on the surface, but we didn't just go to the moon. We had to work up in steps to get to the moon. So there were many different flights that actually led us up to actually astronauts landing on the surface. We had to test all the vehicles. We had to make sure that we could dock in low Earth orbit. We even had to make sure we could go all the way to the moon before we actually landed the astronauts. So there were lots of different missions before the actual 6 missions landed on the surface.
Thank you.
All right, that's great. Let's take a couple more and then we'll meet the crew.
All right, Jack.
When that
Jack.
machine, when that Starlight thing landed on Mars in a crater, will it go out of the crater and explore Mars, or will it stay in the crater?
And we'll definitely have to have a teacher just explain what that student said.
When the rover landed on Mars, will it get out of the crater, stay in, or will it stay in?
Oh, the thing that landed on Mars, will it stay in the crater in Mars or will it get out?
Oh, Curiosity. Yeah, you probably saw or have been following the mission. Yeah, it actually is going to stay in Gale Crater. There's a lot to study in that area. And have you been following the missions? Anybody? There's some amazing imagery. There's a 360 view that I was just able to see just recently. If you go to jpl.nasa.gov or look under Mars Science Laboratory, you'll be able to find pictures from Curiosity. It's actually a large crater. Mount Sharp is about 3 miles high, so it's got lots of stuff to study right there at Gale Crater.
Hey, Jack.
How many Apollos have crashed?
How many Apollo missions crashed? Actually, there was a technical difficulty during Apollo 13 where an oxygen tank exploded, and we had to work really hard to get them back all the way around the moon and all the way back to the Earth. But none actually crashed. There was a fire in the early part of the Apollo program. There's actually Apollo 1 test of the vehicle itself, but that was the only tragedy experienced during the Apollo program. All right, good questions. Now we're going to go talk about analog missions again. We're going to talk about the crew that actually gets to participate in the research and technology studies. And it's a 5-person crew, David included. And I wanted to show you the crew, and Dave's going to introduce the rest of the folks.
Sure. Well, looking at the front row from left to right, we have Mark Reagan. He's an engineer over here at NASA, helping us develop some of the analog projects. He has a couple of different jobs. One of his primary jobs is working analogs, all the various ones, of which RATS is one. He's also what we call a CAPCOM, or a capsule communicator. He sits in mission control, and he's the one that actually talks to the astronauts on the space station during real operations. Sitting next to him in the middle of the front row is Allison Belanger. She's actually a spacewalk officer, so she does the same job I do. She trains astronauts to do spacewalks, so we do a lot of work underwater and show them all the tools they use. And she's also a flight controller, so she sits in mission control along with Mark when there's an actual spacewalk going on and helps direct it. Next to her is Liz Rampy. She is actually a planetary scientist, so she's a geologist. She's an expert on rocks, and she actually specializes in Mars. She's here to give us a real science input into what a scientist would want as far as a spacecraft or tools or anything we'd use to sample rocks off of an asteroid. From the back row, left to right, the far left, that's me. I'm also, like Allison, I'm a spacewalk instructor and a flight controller, so I train the astronauts and sit in mission control and help direct the spacewalks when they go on. And then I also have a second job where I work at helping to develop some advanced and future space tools, specifically for spacewalking. And next to me in the back is Trevor Graff. Trevor is another planetary scientist. So he's just like Liz, came in with some expertise on geology and especially Mars, and he's here to help us understand what the science side of the mission might want.
All right, isn't it true that there are actually some crew members in the multi-mission space exploration vehicle right now?
That's true, yes. Actually, you can kind of hear the engines firing in the background a little bit. So we have 2 people in there right now. Liz and Mark are in there. And they're flying around the asteroid, and all those little thrusts you can hear when they're moving the controls as they fly around.
Okay, well, a little bit early on in the mission, we actually got little introductions from all the crew members. So I wanted you to see all the crew members and hear about what they do here, so you get a little background on them personally. So let's take a look at the crew of Research and Technology Studies 2012.
Hi, I'm David Cohen. I'm one of the RATS 2012 crew members. I work here at NASA's Johnson Space Center as a spacewalk officer, where I train astronauts to do spacewalks and also direct those spacewalks for mission control. On top of that, I work on future spacewalk tools and techniques, and as such, I'm involved in a lot of these analog missions like RATS and like NEMO missions that we do underwater at Aquarius. I've worked on several previous RATS missions and a couple previous NEMO missions, and very happy to support this year as a RATS crew member.
Hi, I'm Liz Rampy, and I'm a geologist at Johnson Space Center. I study Mars. More specifically, I study the minerals that form from water-rock interactions and what those minerals can tell us about past aqueous environments, like the pH, the temperature, how much water there was, and whether or not ultimately that surface was habitable. I've been on the science team for rats in 2010 and 2011, and I'm really excited to be a crew member this year for Desert Rats 2012.
Hi, I'm Trevor Graff, a planetary geologist here at the NASA Johnson Space Center. I'm supporting the RATS testing 2012 as a primary crew member and excited about exploring an asteroid this year.
Hi, my name is Allison Belanger, and I'm a crew member this year for RATS 2012. This is my first year helping out with the RATS analog, so I'm very excited about taking the integral role of being a crew member this year. When I'm not working on RATS, I work in the Extravehicular Activities Office, where we train crew members in all aspects of spacewalking, including how to use tools and how to use their spacesuit, the EMU. And another part of my job is to also work as a flight controller and mission control when the crew members are performing spacewalks.
Hi, I'm Mark Reagan. I'm one of the RATS 2012 crew members this year. I work in the Analog Projects Office here at the Johnson Space Center, and we are looking at the problem this year of how one would explore a near-Earth asteroid. And it's actually part of a series of analog missions we've done this year. Earlier we did a NEMO mission, which is looking at this problem under the sea. This RATS 2012 mission is looking at this problem with some of the advanced facilities and simulation techniques that we have. And between the two, we are hoping to piece together a comprehensive look at the tools and techniques and ops concepts required to explore a near-Earth asteroid. It's going to be fun. I'm looking forward to it.
All right, so that was the crew of 2012 Research and Technology Studies. So we've got a lot of things going on. They actually get to go to a lot of different facilities around Building 9, the Space Vehicle Mock-Up Facility. And I wanted to show you a few right now. Do we have a question? Did I hear somebody?
No question.
Okay, excellent. Well, if you do, definitely raise your hand and let us know, and we'll stop and answer your questions. Now, the different areas that the crew members actually get to go into are some really amazing facilities and some amazing places. So let's go ahead and start talking about our first one. It's the MMSEV. NASA loves acronyms, and that stands for Multi-Mission Space Exploration Vehicle. Whew, that was a mouthful. So what is MMSEV?
Well, like you said, it's multi-mission, which means that you can use it for multiple missions. What you see there is it's on a sled, and for a mission to an asteroid, you would have thrusters on that sled and it'd fly around the asteroid. If you were visiting a planetary surface, you would put a wheeled chassis on it, and it would essentially be the same cabin, and you could go multiple different places with it. And so it has multiple screens in the front, navigation screens. You can drive the vehicle from there. You can go to an EVA controls when you're ready to use your suit ports to go outside and perform a spacewalk. And it also have communications back to Houston from there. And
is it pretty spacious inside?
It is pretty big. This is called the Gen 2A vehicle, which means it's the second generation vehicle and the first version of the second generation.
Okay. Excellent. And I actually think we have a video that I'd like to show, and maybe Dave can talk about what it's like to actually fly around inside and manipulate things inside.
Sure, yeah, this is so we're sitting in the cabin, this is Trevor and I, and we're flying around the asteroid. And there's a real windows in front of us, and what we're looking at is a projection screen out front, and they put the asteroid simulation out there. So it's kind of like flying a big video game. We can use that joystick off to the side there and control the MMSEV. You know, we can fly any way we want. We can fly in and out, up and down, left, right. We can pitch and roll and yaw, just kind of like you were flying an aircraft in a video game or something. So, and it feels very real. They made the simulation so good that it seems exactly like you're at an asteroid.
Yeah, it looked amazing. When you were rotating like that, I was getting a little dizzy just looking at it. That was awesome. So all the crew members get certified to fly the vehicle?
Yeah, we trained everybody on it. So even this is Liz, one of our geologists. So she's one of our science experts. We trained her how to fly the MMSEV. all of us take turns doing it for the mission.
Excellent. But you also have to live in here as well, right?
Yes.
So how is personal hygiene and sleeping and eating and all that kind of stuff? Is there enough room for everything?
It's actually not too bad. It's like living in a really large van. So, you can do anything for a short period of time. Trevor and I lived in there for 3 days, and right now Allison and Liz are living in there.
Okay.
And so, yeah, we have little bunks we can sleep in and curtains we can draw around it for a little bit of privacy. We have all the amenities pretty much you'd need.
Okay.
But it's sort of like a camping trip.
Did they leave you all alone, the people in Mission Control, or was someone there all the time so you could talk to them during your?
There's always someone here watching over us, make sure we're doing all right. But once night comes around, we're pretty much on our own. We kind of handle our evenings and nights as we see fit.
Wow, that's interesting. But I would absolutely love to get to fly that, because that looks like the best video game I've ever seen.
It really is.
How many windows? 8 windows around?
Yeah, I think there's like 7 in the front and a couple on each side.
Oh, sideways too. Okay.
So quite a few windows, and they put the simulation in all the windows. So you can look out any window in the vehicle, and it looks like you're at the asteroid flying around.
That is so cool. Excellent. So that is the multi-mission space exploration vehicle. All right, excellent. Now, before we go on to the next section, does anyone have any questions about the MMSEV? Oh, there we go.
About the MMSEV, about another machine. Is it true that one machine carries rockets and goes at an average speed of 2 miles per hour, yet the driver has to wear a seatbelt?
They were talking about the MMSEV and having thrusters to move around. Do you guys have to wear seat belts? And where will it be flying? Maybe give them an idea of where it's going to be going and how you're going to move around in space.
So this MMSEV would be flying in free space. So there wouldn't be any gravity around it. They'd be flying around an asteroid. It really depends on which asteroid we go to. There's all kinds. There's ones that are several miles long. There's ones that are just a few yards long. So we'd be flying around that in zero gravity. They do have rockets, so little thrusters all around it. That's enabled us to maneuver different directions as we move the joystick. We wouldn't have to wear a seatbelt per se flying, because we're flying at really low speeds and we're very careful where we go and there's not much to hit. But we would have probably some sort of restraint to help us stay in our seats. The hard part is floating out of your seats. You want something like a seatbelt to keep yourself seated.
Yeah, you push on the computer screen and you go floating the opposite direction.
Right.
Or are there foot restraints maybe, or maybe some lap restraint?
Actually in this cabin there's nothing, because we're sitting in gravity. But, we'd have something, and we're still probably working out exactly what we want that to be, and something you can use for long periods of time.
But good thinking, yeah. When we're in microgravity, we're definitely going to need to stay in one space. Otherwise, we'd float off and wouldn't be able to do the important jobs that we need to do when we're traveling out to an asteroid. Good thinking. Next question.
Right here in the front.
What's NASA stand for?
Ooh, that's a tough one. Does anybody in the crowd know what NASA stands for? Let's break it apart. What do you think the N stands for?
National.
National, the entire nation. Excellent job. What do you think A stands for?
Aeronautics.
Ooh, good job, aeronautics. Not only do we do spaceflight, but we also help planes fly safely. We've got Langley Research Center with over 20 wind tunnels that test modern aircraft. Make sure they fly safely and more efficiently. Good job. Now, what do you think the S stands for, everybody? A's. Excellent. Now, the A one is really tough. Does anybody know what A stands for?
Association.
Oh, pretty close. Association. That's a group. Actually, it's administration, but it's a big group of people working together for a common goal, to explore space and benefit humanity. Great job. So NASA is National Aeronautics and Space Administration. That was a fun one. All right. Now, you guys ready to look at the next area? All right. Excellent. And it is called Argos. And that stands for Active Response Gravity Offload System. Once again, that's a huge mouthful. Basically, they're trying to simulate what it would be like to work in a microgravity environment. Now, you can't just flip a switch and gravity just goes away. So we have a very special harness system and pulley system that actually can hold the test subject's weight, and so they can simulate what microgravity is like. So what was this like doing the Argos?
Oh, this was actually a whole lot of fun. When we're flying the cabin, we're doing a virtual reality, so it's like you're flying in a video game. But when you're on Argos, like you said, you're hanging in this harness here, and that harness is being suspended by a cable. And we have computers that control the cable, and it can pull it up and down, move it left and right, and in and out. So whenever you touch something, the computer knows which way to push the cable. It makes you float away as if you were in space.
Oh, wow.
So when you're on there, you feel like there's no gravity on you, and you're just maneuvering around as if you're in a zero-G environment, like you're an astronaut. And this is great because it enables us to hold real tools and do real geology. So we can get a real hammer and hammer on a real rock and see how our bodies will respond and how our tools will respond in an environment with no gravity.
Okay, and it's really amazing because it's not just one little area that you can work at. You can actually go really high, you can go really low, you can go across maybe, 20 or 30 feet?
Yeah, this is showing the top of the cabin, actually. You can actually get on top of it, so it's quite a bit of ways up, and you have quite a length you can go to.
Yeah, it looks a lot of fun. Did you fly like Superman?
Did. Can't help but do that.
All right, excellent. So he pushed off one side and flew all the way across the Argo system so he could see what it would be like to float through the air. All right, does anybody want to do that someday?
Yes.
All right, yeah, looks like fun.
Fun.
Yeah, I would definitely love to do that. All right, excellent. Now, that's not all. There's also amazing areas where we can actually simulate environments in virtual reality. And I've got a couple of pictures here. Anybody want to talk about the virtual reality lab?
Sure, okay. Yeah, the virtual reality lab is quite a bit like a video game. It's an area where we can put on basically a set of goggles. You can see this is Allison doing her training. She's got those big black goggles around her face. Well, inside those goggles are little screens, so it's kind of like the TV we have in front of the MMSCV or watching a TV. But you see what the computer graphics are showing you. So to her, it looks like she's at an asteroid, and she can move her head around, and the view moves as if she was really there. She's even wearing these black gloves. These black gloves allow her to move her virtual hands, so her little computer graphic person hands move as she moves her hands. And she's sitting here holding the controls for her jetpack. So what she's doing is she's actually, to her, it looks like she's at an asteroid. She's holding on to the controls of the jetpack, and she's flying around that asteroid.
Okay. So it's a completely immersive environment, and she's seeing. Is this a representation of some of the stuff that they might see?
Yeah, this is what you might see when you're in the virtual reality lab. So you have those glasses on, and this is the kind of view you'd have. So what you see here is the asteroid in the background. You see the MMSCV, it's a little computer model of that. And on the front, it's a little hard to tell, but there's actually a little crew member in a white spacesuit. That's the other crew member that would be out with Allison collecting samples on there. So this is how it looks to us. So you can see when you're just sitting there in a chair, to an outside observer, you just look like you're sitting there in a normal office.
Wow.
But to you, you look like you're actually at the asteroid doing activities.
Oh, that's amazing. And as I looking at this image right here, it looks like there's two chairs. Can two astronauts simulate what it's like in virtual reality?
Yes. So we can put two people in there at the same time. And so we can have two people helping each other out outside of the spacecraft, collecting samples or watching each other.
And they're both seeing this computer environment. So if they turn and look, they might be able to see the other person, and they can look back at each other.
That's right. Yeah, you can turn and look at each other. You can use those gloves to wave your little computer-generated hands at each other.
Wow, that's awesome. So you guys definitely need to continue to study math and science. Come work at NASA, do all these amazing, cool things like virtual reality or Argos, or like this SEV right behind us. Excellent job. Now, I'd like to take time to really focus on your questions. So that was all of our main presentation. Now I want to see if you guys have any questions about all the things we talked about today, or about any things about NASA or spaceflight.
This young lady right here, stand up so you can hear me.
About NASA, are you guys working on how to get to farther planets beyond our galaxy?
Are you working on how to get to farther galaxies or out into space, way out into space?
Oh, we are trying to go further and further into space. In fact, we've got lots of vehicles that are traveling out there. Like New Horizons is on its way to Pluto. And after that, it's going to go see if there are any more dwarf planets out there beyond. Voyager 1 and 2 are on the edge of our solar system. They're still going out there. But for humans, we're trying to work on that right now. And that's one of the things that the analog missions are helping with, right? To get humans farther and farther away from our home planet. So who knows? It might be going to asteroids, it might be going to Mars, and this groundwork that we're doing right here is going to help us do that. So yes, hopefully we'll get further out there. One thing we might need is faster propulsion systems to get out there faster, because space is huge. Think about it, just getting out to the outer planets, it's millions and millions of miles, hundreds of millions of miles. So we're going to need to go faster and quicker to actually explore that. Good question.
Grace?
When will be the next space mission?
When will be the next space mission?
Yes.
Oh, well, we've got them going on right now. In fact, since the year 2000, we've had people living and working up on the International Space Station. We're already at Expedition 32, and we've got 6 people living and working up in space right now, and monitoring their health and safety are mission controllers right here in Building 30 at the Johnson Space Center. So we've got missions going on continuously right now up in space. They're about 240 miles up, orbiting around the Earth about every 90 minutes, and we're continuing to do amazing space research on the International Space Station.
Alexis?
How long did it take to go to the moon?
How long did it take to go to the moon? You guys know? About 3 or 4 days?
About 3 days.
Yeah, about 3 or 4 days to get actually to the moon, and then they stayed down there either for hours or maybe one day, and then they actually came back during the Apollo program between 1969 and 1972. Next one.
Katie?
Is it true that you can get to Mars, but you don't because you're working out with what happens to the bones in your body once you go into space?
I think I heard most of that. We actually have thruster firings right behind us, so it does make it a little bit difficult to hear you guys. So if you guys could speak up, but I think the question was about Mars and how it's going to take a long time to get there, and won't our bodies be affected by going that far out into space in that microgravity environment? They will, won't they?
Yeah, the astronauts will have to exercise to stay healthy.
Yeah, we're learning a lot from the astronauts that are up on the space station. They have to work out about 2 to 2.5 hours every day so they don't lose calcium in their bones. They keep their muscles strong, and their internal organs and their systems, body systems, don't get affected by that microgravity environment. But it's going to be harder when we go to Mars because it's going to take a lot longer to get there. Good question.
Yeah.
How long has the thing been going to Pluto?
Oh, it actually launched a New Horizons. It launched in 2006, and hopefully it'll get there in 2015. So it takes 9 years to travel all the way to Pluto. On average, about 3.6 billion miles away from the sun. So it takes a long time to get it way out in the far reaches of the solar system.
Kayla?
A lot of astronomy.
Considering people are in the spacecraft for more than a day, how do you keep food in this spaceship?
Oh, we pack it in tight. So there's lots of spaces here and there, and wherever you turn, whatever drawer or lid you pick up or open, there's food there. So they found a way to pack stuff in as well as they can. And actually what we've been eating is a lot of freeze-dried food. So we'll take food and take all the water out of it and put it in really small packages. And you take water and inject it in there, and it swells it back up to pretty much normal, and you eat that. So freeze-dried food that's packed in everywhere.
So you're doing very similar to what the astronauts on the space station eat?
Yes.
Okay, excellent, yeah. And it's a big menu item of things you could choose to eat. It's just packaged and prepared a little bit differently for the journeys up into space. Yep. Okay, excellent.
Shot.
All right, another question.
How close can you get to the sun?
You want to know how close can you get to the sun?
Oh, that's a good question. Well, the Messenger spacecraft that's going around Mercury right now has to have this huge heat shield on one side and always has to face the sun, because if it didn't, it would completely burn up the spacecraft. Actually, I'm not sure about that one. Do you know that? Yeah, I don't.
Yeah.
Millions of miles, definitely. Like I said, we have to really protect. We've got the Solar Dynamics Orbiter, and that's several millions of miles away from the sun itself. So I'd say really far away.
We have maybe 3 more minutes. We got time for one more. Drew?
Okay, excellent.
The rover that is going to Pluto, were you guys worried when it was going across the asteroid belt?
Oh yeah, and we actually monitor that. We make sure that its path is hopefully not in the same trajectory as where the asteroids will actually be. And that's one great thing about space. It's very, very big. So even though there are thousands of rocky bodies orbiting around the sun and the asteroid belt, they're really far apart from each other. And so we make sure that we make the right trajectory or the path that those satellites take so it won't be in contact with any of those asteroids. Good job. I love how you guys are thinking, especially for long duration missions out into space. All right, so do we have time for one more?
All right.
Okay.
What happened to the Galileo space probe?
What happened to the Galileo space?
Yeah.
Actually, I'm not sure. I'll actually have to do a little research, and how about this? I'll send you an email to your teacher at the end of the program, and I'll let you know. Okay?
Thank you.
All right. Thank you guys very much. On behalf of Barbara and David, I want to thank you guys for joining us here at the Johnson Space Center in the Space Vehicle Mock-Up Facility, Building 9, and learning a little bit more about analog missions. Bye, everybody.
Bye.
Thank you.
That was so fun. That was awesome. Talking to